Hello YouTube, this is Jay Coder back with another stream, and right now I would like to go over a video about ML Kit, Machine Learning Kit for Android. They have a couple of features that I want to take a look at with you guys. And if you like this kind of content, please subscribe to the channel, comment on the video, and like the video. And without further ado, let's go ahead and get started. Alright, so I'm gonna play the video. It's from the official Android development YouTube channel. And let's go ahead and check it out.
Hello everyone, welcome. I'm Zhongling Sun, a software engineer on Google MLKit. Together with my colleague Valentin, we're going to go behind the scenes on two of the most popular APIs from MLKit, Text Recognition v2 and Pose Detection. MLKit is Google's machine learning SDK for mobile. It brings Google's machine learning expertise to mobile developers in a powerful and easy-to-use package. Make your Android and iOS apps more engaging, personalized, and helpful with solutions that are optimized to run on mobile devices. Most importantly, it's free to use. Since MLKit launched in 2018, we created 12 unique APIs with some of the best machine learning models Google has to offer, covering core use cases in vision and natural language processing. We provide regular updates and new use cases. We have moved out of beta and put quality assurance as our top priority, ensuring production users are in good hands. Each API is naturally different, but they share a common infrastructure that provides stability and optimal performance. The MLKit SDK manages all the complexity of multiple models, image processing, TensorFlow Lite runtime, hardware acceleration, and much more, delivering a complete and easy-to-use solution. MLKit APIs are in Kotlin and Java for Android, Swift and Objective-C for iOS, with documentation and sample code for them all. I'm excited to announce that MLKit has more than 40,000 monthly active apps, including many top brands. Text recognition is one of the most popular APIs on MLKit. In V1, it enables recognition of text in any Latin-based character set. It can be used to automate data entry tasks, such as processing credit cards, receipts, and business cards, with support for real-time processing, and it's around 65 kilobytes per architecture as an unbundled library through Google Play services. It's a lot in a small package. Now, I'm thrilled to introduce to you Text Recognition v2 and some big improvements we've been working on. With new pipeline models baked in, Text Recognition v2 is even more powerful. It has all the features from v1 as well as several new capabilities. Support for multiple scripts beyond Latin, deep paragraphing, which provides better structural grouping across various layouts, all orientation recognition, and is more than 30% faster. The most exciting feature of v2 is the ability to support multiple scripts. In addition to Latin, there are 4 new scripts: Chinese, Devanagari, Japanese, and Korean. Under the hood, each one corresponds to an independent TensorFlow Lite model that also supports Latin script. You might not need all of them at once, so you can choose one or more of the 4 options. Together with the existing Latin-only option, there are 5 options available. This allows for high flexibility and reduced installation size on device. Altogether, v2 now supports 37 languages, representing around 4.9 billion people worldwide. we are proud to dramatically expand support to so many more people. When we talk about text recognition, what we care about is not only the characters, words, or lines, but more importantly, the meaning. Even if every line is processed accurately, breaking them apart may not make sense. Thanks to deep paragraphing, words and lines are intelligently grouped into sentences and paragraphs based on the context. From the user's perspective, they see not only the more meaningful results, but also reduction of ambiguous recognition due to the lack of context. This is a significant quality improvement with minimal additional cost. Last but not least, V2 recognizes text written in all orientations. Here, a piece of Latin text that has been rotated 90 degrees can be recognized in V2, but not in V1. This is especially helpful for scripts that are commonly written vertically. With these Chinese and Japanese scripts, horizontal text, rotated text, and vertical text can all be recognized. All orientation requires more computing resources and is currently offered in the 4 new script options. Now let's take a deeper look at how V2 works behind the scene. Recognition lifecycle. A recognition lifecycle consists of 4 main sequential steps: detection, script identification, recognition, and language identification. Detection is to detect the location of the text. Script identification is to identify the script of the detected text. Then comes the recognition step, where corresponding models are applied. Finally, it tries to determine the language it belongs to. The recognized text is segmented into blocks, lines, and elements. Roughly speaking, a block is a contiguous set of text lines, such as a paragraph or column. A line is a contiguous set of words on the same axis. An element is a contiguous set of alphanumeric characters on the same axis. Here you can see them in a descending order. The first highlighted part is a block of text. The second set of highlighted parts are lines of text. Finally, the third set are elements. With V2, there are 5 independent libraries corresponding to the 5 options mentioned previously. The workflows are similar across libraries, but with their own TensorFlow-like model. All MLKit APIs are designed to be easy to use. Text recognition is no exception. Now, let's see how easy it is to integrate V2 with just a few lines of code and start using it today. First of all, let's add a dependency in the Gradle file. In this demonstration, there are 5 dependencies listed. By name, they correspond to the 5 libraries mentioned previously. Each is independent of the others, so we will just add the ones we need. For example, if we only want to support Korean and Latin, only the highlighted part is required. Secondly, we need to create an instance of the text recognizer. In V1, there's only one option available, which is Latin only. But V2 provides 5 different options. The main difference between V1 and V2 APIs is that V2 uses text recognizer option classes to choose the desired option when creating a text recognizer instance. For example, a Korean text recognizer option is passed into the static function getClient to create a text recognizer instance for Korean and Latin. Once we have the recognizer, we also need the input to start the recognition process. Just like V1, the V2 APIs take an input image. In the demonstration, it shows how to create an input image from byte buffer. But note that the input image can be created from many other common formats. Now, we have both the recognizer and the input image. It is time to kick off the recognition. All we need to do is to pass in the input image to the recognizer's process function. and set up listeners for result handling. The result is returned in the format of text class, which contains information about nested blocks, lines, and elements. Each layer also has additional information about corner points, bounding boxes, and recognized language. And that's all you need to integrate Text Recognition V2 and start using it. If you're interested in learning more, we have online resources including detailed guides, sample apps, and API references. Just search Google ML Kit and start from there. Next, I will hand over to my colleague Valentin to talk about pose detection.
Hello, I'm Valentin and I will present MLKit pose detection. When we started this project, we aimed to develop an API that would be beyond the existing state-of-the-art solutions and would work in real time on a device. And today we have one. MLKit Pose Detection API provides both 2D and 3D key points, supports custom pose classification, and has the industry-leading quality for the most demanded mobile use cases such as yoga, dance, fitness, and sign language. In the recent release, we added 3D key points, which provide relative depth and unlock pose analysis in a 3D space in a view-invariant manner, which simplifies pose estimation a lot. Let's have a look at the pose topology. We extended the existing de facto standard 17 key point Coco topology with hand, feet, and face key points, which are marked with yellow on a figure. And now it is possible to estimate scale and rotation for hands and feet, for instance. MLKit Pose API is available in two mobile platforms, Android and iOS, in two versions, Lite and Full. And in addition to that, the same pose solution called Blaze Pose is also available in MediaPipe and TFGS via Python and JavaScript. Let's have a look at how to use it. First, we should select a mode, which can be stream mode or single image mode, and then create a pose detector object. Then we process the image with the pose detector, and that's it. If a person is present, the pose would be detected. Now let's have a look under the hood and see how it works. Our pose detection API is a two-step pipeline consisting of a pose detector and a pose tracker. In the first frame, we run the detector, which locates a rough area around the person, which we call person box. If the person is found, for this person box area, we run the tracker model, which detects accurate locations for all the key points. For the subsequent frames, the logic is a bit different. We estimate the person box based on the key points from the previous frame. In addition to key points, the pose tracker model also predicts if person is located in this person box. If not, we restart the logic and run the detector again. A couple of words about person box. In our case, it is oriented, so encodes not only position and scale, but also a rotation as shown in the video. We encode person box via two auxiliary key points, which are predicted both by detector and tracker. Recently, we added 3D pose, and it is a vital component for such applications as motion capture, AR effects, and angle-based pose representation. However, the main challenge for 3D poses is data. In contrast to 2D, it is impossible to annotate existing photos or videos manually. There are three main approaches, which are common nowadays. First option is to create a synthetic dataset. However, this usually introduces additional challenges with domain transfer and realistic poses. The second option is to collect data in the lab by multiple cameras and sensors. However, this approach lacks a realistic environment. We decided to go with a third option, which is to use the existing 2D dataset, which does not have issues with the realistic environment or pose articulation, and feed it with a statistical body pose model. For this purpose, we took the generative parametric human model called GAM, which was recently released by Google. It is based on a 3D body scans supports full body articulation, nonlinear body shapes, and facial expressions, so it perfectly fits our case. We did the fitting by optimizing pose and shape via the next objectives: 2D key points alignment, body silhouette alignment, and additional shape and pose regularization to preserve realistic poses. And then, based on this 3D ground truth, we trained our pose detection models. Another use case that many developers need is custom pose classification. To ease the usage of our pose detection API, for pose classification, we recently released an example in a MLKit Quick Start app and MediaPipe collab to prepare the data for developer-defined custom poses. Let's have a look at how to set it up. First, we need to collect images with desired poses from different viewpoints, lighting conditions, and different people performing this pose. Usually, a couple of hundreds of samples per posture should be enough for the start. Once collected, you just need to organize these photos in folders so all the samples per particular class are located in the same folder. Please note that the folder name would be the posture class name. Once collected and organized, you will need to attach this data to MediaPipe collab and then update the input folder and output CSV file variables. Additionally, for debugging purposes, you can set up output folder variables and see the key point visualization for your images. Then you'll need to run the collab, which prepares the CSV file. Third and the last step is to build the MLKit Quick Start app. You will need to attach the generated CSV file and update pose samples file and pose classes variables according to your case. And that's it. Once the application is built, you will have your own custom pose classification. For more details, you can read our blog posts that we released recently about Blaze Pose, which is a model behind the MLKit Pose Detection API, and Holistic Pose Tracking blog, which is a more sophisticated pipeline built on top of Blaze Pose and provides 540 key points with detailed hands and face articulation. Thank you.
So yeah, that's some pretty neat applications for that. The ML for MLKit, where they had the pose and the text recognition. The pose seems like it could be used for video editing as well, where you can have it manipulate 3D models or 2D models on your actual video. But yeah, thanks for watching, and if you like this kind of thing, please subscribe to the channel, and as always, stay coding. All right, peace.